Hello and welcome to the 7th episode of Build on Open Source. My name is Ricardo Suarez. I'm a developer advocate at AWS. And Derek, hello.
Hi, Rick. How are you going? How's your Friday morning over there in the UK?
My Friday morning is it's actually okay. It's not raining for a change. We've had a lot of rain recently. So much so that I've invested in a good pair of flippers. But no, it's going good. I'm feeling a bit broken today because I've been doing a different kind of building this week. I've been doing physical building. But yeah, so all good.
You should just go easy on the physical building. Mental. Should all be mental.
So welcome everyone who's joining us today. Build on Open Source. This is a show where we talk about open source projects, all the latest ones that you can check out. We go through some open source news. And then later on, we're going to bring on a special guest. And we're really, really lucky today. We've got a great guest, Vinod Chandar from OneHouse, who's going to be talking about Apache Hudi. So stay tuned, folks, because he's going to introduce you to what Apache Hudi is, go do some really cool demos. So I'm really excited about that because
get your hoodie questions ready.
And I'm wearing my hoodie, so I've got my hoodie. It's not an Apache hoodie. So which actually, that's going to be interesting. We can ask Vinod that. Are you hoodies? When is that the collective term?
What is it? What is a collective noun for a hoodie?
For the community, maybe they should be called the hoodies. But we can ask Vinod when he comes on later on. Next, so we're not actually in 2 weeks' time. We won't be having a show for everyone who typically tunes in every 2 weeks because Derek, where are we going to be?
Well, Rick, yes, I've been spending the week getting ready for this. Las Vegas, we're going to reInvent. We're both going to be there.
We are.
And you can come. Well, I'll be around the developer lounge. I'm building an app at the minute to track or to get answers from the community on what's their favorite programming language and questions like, what's your favorite service or what is a service you want to know more about. So I'm building that app at the minute in .NET and that's taking quite a lot of my time because as we said before we came on, you forget that when you have to deploy things to production, you have to log. You don't log the console, you log the file.
I do.
And there's all these things that I've forgotten that I've been relearning this week. What about yourself, Rick? What are you doing at reInvent?
So I'm doing a talk on Apache Airflow at reInvent, but also I'm going to be hanging out at the developer lounge. We've also got an open source kiosk. So if you are coming to reInvent in a couple of weeks' time, try and find Derek and myself. We've got loads of other open source folk that are going to be around, but we do have a booth and we're going to be doing demos. So some of the community are going to be showcasing some of their open source projects there, as well as some of our internal teams going to be talking about some of their open source projects as well. So if you're at reInvent, come to the booth. I will be bringing some exclusive swag. Yeah, so there's an incentive for you, okay, to come along. If you can find us, then we might give you one of these lovely coins. So sorry, yes.
I was just going to say, Rick, if you can't make it to Las Vegas, let's be honest, not everybody can. We're also having a live stream over the 3 days of reInvent on Twitch TV/AWS. Well, we'll bring you all the goss from the conference itself, and you can tune into that on this channel as well.
Excellent. So the next Build on Open Source, episode 8, is going to be on the 16th of December. We're going to be featuring an AWS community builder, Ran Eisenberg, who's going to be talking about some of his open source projects. So that's going to be the next one we do live. So just a heads up in case you're wondering where we disappear to next week. So that's all from the intro. We do have a new prop. We've got a bell.
Love a good prop.
and I'm going to use this to control Derek, right? So this is going to be how we do this, and it's going to be my transition. But before we transition, I just want to say hello to Wellington Marudo. Wellington, I hope you're watching. Wellington's been helping me with the. In fact, I've been helping him with the building work. He knows what he's doing. I don't.
Who's in control, Rick? Who's in control?
Exactly. Yeah. So with that, let's crack on and look at the open source news and projects.
Wow, the Derek remote control works.
I'm so glad that worked. In fact, I was so overtaken by the fact that the ring worked that I forgot to share my screen. So for folks,
we didn't debug that beforehand either.
We did not. So for folks tuning in, this is a show where we walk you through the latest open source projects. which I'm going to do over the next 10 minutes. And then we're going to bring a special guest on, Minos Chanda from One House, who's going to be talking about Apache Hudi. All the stuff, all the content we're sharing today is available in this GitHub repo, so you can check out afterwards. So there's 2 newsletters to go through, and there's some absolute corkers of projects. So last week I published 135. Okay, so I'm going to walk through very quickly some of the key ones. So the first one is workload discovery on AWS. And this is the project. So AWS often releases a bunch of open source projects that allow you to do some stuff. And so what this project does, it allows you to actually effectively create a solution to search and find and report on all your AWS resources across all your environments. Okay. And so it's really detailed. There's a document that shows you how it works, as well as how to deploy it. So very well worth it. If you've got large workloads or you want to make sure you keep up to date with them, it's a really good tool. And actually,
sorry, Rick, does it also draw them like you're showing there?
I don't think it does. That's just the documentation.
Yeah.
I like it when a project has a nice architecture diagram, don't you?
Yeah, it's very pretty.
Yeah. So next project, again, prolific AWS community builder Lars Jacobson. He of ASCII art fame.
He is the king of ASCII.
He is the king of ASCII, but he is also king of creating CLI tools. Now we released a new capability, Resource Explorer. Okay, and it's a thing that I'm not sure if you use this, Derek, but allows you within your AWS environments to, you've got to switch it on, you've got to enable it, and then it basically indexes all your stuff within your AWS environment. Okay, and then you can actually search through the search bar, and so that's great if you're in the console. But what if you're in the CLI? You need a CLI, right? So Lars has got your back, and he's created a CLI that helps you do that. He's always doing that. So
he is my kind of person.
We love you, Lars.
Yeah, it's like,
love you, Lars.
Who needs web when you've got a CLI?
Exactly. I'm a CLI guy, so you know. Next project, again, another cracker of a project. So this one is, I'm gonna kind of open this one up. This is from AWS Serverless DA David Boyne. He's created this new project called Schema Watcher. But what I love about this project, and most of the stuff that David does actually, is he creates absolutely incredible documentation. So let's have a look at this. So this is a thing of beauty, right? And I wish a lot of open source projects would do the same thing, because it really makes it easy for you to understand how to use a project, how it works, how to get started. And so effectively what this project does, okay, is if you're building event-driven architectures, one of the things you need to be aware of is, as schemas change in your upstream or downstream, how do you make sure that you stay on top of that? Okay, so this project allows you to effectively notify the consumers of your sort of schema, the consumers of your events to be updated when the schema changes. Okay, and it does it through a Slack, email, or even an API. Right, so super interesting.
The Docker was always awesome. Docker was always awesome in David's projects.
They're really good. So definitely want to check out. I'm getting a bit confused because I've got 2 screens here. That's why you see my head moving, because I've got 2 screens. So it's not. I don't have a health problem. I promise. Next project, okay, AWS Serverless Scheduler. So this one is a fork of another scheduler project, but basically allows you to schedule ahead of time a Lambda function to do something. So if you wanted to do something in 20 minutes, you could create that, and effectively I'll actually open the project so you can actually see it. But what you do is you deploy this, and then you put in a payload. So here's the payload. So and the payload includes the timestamp of when you want the Lambda function to run, and you can do some other things, such as, for example, having some optional payloads, headers. And there's an example here of how you would actually do that through a Python file. So to schedule a Telegram, for example. So interesting, and it's a more specific, narrow use case than a project it forked from.
Yeah, because didn't EventBridge release scheduling this week as well?
Oh, did they? Okay, I did not know that.
Yeah, so this is a lot narrower.
Okay, cool. So then we've got CloudEnv. CloudEnv is kind of a proof of concept. So not really a project. It is a project, but what he's done, okay, he's put together a way. So we introduced a new capability in Lambda functions to inject secrets and parameters in your Lambda functions, okay. But what Aidan's done, okay, is he's created a different way of doing it. One that's consistent with ECS if you're using ECS, and one that basically follows kind of like sort of the kind of 12-factor manifesto, right, of injecting secrets as environment variables, integrating with parameter store and secret manager. So it's a different way of doing it, and he's actually looking for feedback. So if you've got thoughts on this, then get in contact with look at the project. He's written a blog post about it, so get in contact with him. And then we got a couple of in fact, last week we had a couple, and this week we've got one as well, which I'm going to come into in a second, of projects that are around security. So Nitrogen is a really cool project, okay, that allows you to easily get started with Nitro enclaves. I know we talked about this last week in our last show, but this one actually has got some really nice demos, right? So there's two demos. One's My Secure Mortgage, and the other one is Secure Sentiment Analysis, okay? And it allows you to, it's a CLI that allows you to get started deploying applications that use Nitro enclaves. And so just for people who are tuning in, Nitro enclaves, if you think about, as we try and encrypt everything, so encrypt transport and your payloads that way, you still have to, when it gets to a host, you have to unencrypt it, okay, to then do some processing. And potentially that's something that some people want to have more security on. And so enclaves allow you to effectively create a secure environment within your EC2 instance host, protected by the Nitro hypervisor, that allows you that provides then attestation and encryption to then allow you to control how you can run your applications in that secure Nitro enclave without exposing it to the external world. So you communicate through API. So it's really cool stuff, and it's part of this kind of confidential computing movement.
Really gaining momentum at the minute.
It is. It really is. And so Nitro, it kind of lowers the barrier for people to kind of get started. And there's another project this week as well, which I'm going to come to quickly as I wrap up this last week's. Then we've got Sovereign Keys, which is an interesting project that allows you to use and effectively provide encryption to your workloads in a way that allows you to effectively have more control than if, for example, you were just to use a standard kind of encryption that AWS gives you, okay? And really where it's coming from is to try and, it's not to say that you can't trust your cloud provider, but it's around showing and demonstrating that actually there's a level of security that you can provide yourself. That means that if you were asked, if your cloud provider was asked by a legal entity to provide that, then there's actually nothing that they could do because the customer has actually got this solution to encrypt their workload. So it's and they've actually got this project, and it's like super long 1.5 hour video that walks through the whole solution. Right now, I didn't manage to get through all of it, but I managed to go through a big bunch of it. It's really cool. So do we have any questions coming through?
Nothing yet. Just people asking over your pensioners club, which is pretty close.
Oh yeah, pensioners club. Okay, that's harsh. That's harsh. Although to be fair, I feel a little bit like it at the moment because of my building shenanigans. Right. So because we want to move swiftly onto this. So I'm currently working on the current newsletter. Some great projects coming up. First one is a GUI. Okay, built in Java FX. I've not seen that for a while. That allows you to effectively interact with your DynamoDB, both writing and editing content. So I'm definitely going to try this out and see how good it is. So
I haven't seen anybody use Java FX for a very long time.
Yeah, exactly. It's old school, right? It's old school.
Yeah,
keep that Java FX stuff coming in. We love it. There's a few projects this week on Apache Kafka. So this one's from one of our colleagues, Ricardo, the other Ricardo in the team. Where there is two. I know sometimes I try and monopolize the Ricardos in our team, but we do have the good Ricardo Ferreira. Sorry, Ricardo, I hope I said your name right there. So he's created a sample repo that allows you to understand how to build Apache Kafka connectors, okay? Because they're super hard to do. Lots of things you need to think about, and he's created like a vanilla one that you can use as a baseline for yours, which is great. One of the things I love about open source is the 4 freedoms, and here you go, the 4 freedoms in action. Next one, we've got MSK config providers, and cool. Yes, no worries. Yeah, it's a great tool, Zed Engerman. So
it is that time of year as well.
Yeah, exactly. So the MSKS config providers provide some sample config providers classes for interacting with security manager, parameter store, and SS3 if you're using Apache Kafka. So quite often it's how you actually inject the configurations into Apache Kafka. So it's a really nice repo that contains examples for folk. The STO-RS is really if you're working in medical imaging. STO-RS is a standard. I learned this for the first time. It's a standard of doing images, so things like X-rays and scans, all that kind of stuff. So there's a project here that allows you to do that straight to S3, which is pretty cool. Yep. And then we got this one, which is a really nice project. Okay, so for IoT fans, AWS Device Lobby allows you to really easily onboard your devices to AWS IoT. I can't even say that.
Yeah, IoT Core. This would come in handy with the app I'm building, which is MQTT, the IoT Core, and I'm having to manually onboard all
the
devices. Yeah.
You feel
Where were you, Device Lobby? Last week.
Where were you exactly? Yeah. And then just two more before we go to the transition. So HPC Builder, okay, this is effectively a bunch of scripts, okay, that allow you to easily install all the tools you typically need if you're doing HPC on Amazon Linux 2 or 22, and it works on Graviton or x86. So if you're doing HPC stuff, this tool will help simplify how you get all the various tools, and it actually within the project tells you all the tools it supports, and you can install just some of them, all of them, that kind of thing. And the final one, because this project is super hot at the moment, Stable Diffusion. So there's a sample notebook on how to get Stable Diffusion running on a SageMaker endpoint. So I've loved playing with these AI generative tools, and I'm getting them to use a lot. Well, actually, I've just realized I've done a typo there. It's not DALL-E R, it's DALL-E E. So apologies there. I'll fix that. So definitely, if you're interested in these kind of tools, definitely play around with it. Actually, there's one more. So I want before I was talking about.
They're a great way to create content for your slides.
And we have we have one speaker. So I've been mentoring one of the speakers at reInvent. Yep. And she has created all her images using DALL-E, and they're awesome. Yeah. They're really good. So before we transsition, I mentioned a new Nitro Enclave project. So this one here allows you to do confidential ML workloads using Nitro Enclaves. Really interesting because it shows you how you can solve the problem around, if you've got confidential data you don't want other people to have access to, and you want to use it in things like training or inference. Then this is a sample solution that allows you to learn how to do that. So definitely worth checking that out. And we've got lots of other projects, but we don't have time because I want to make sure that we give as much time as possible to our special guest. So with that, I think we should transition to next section.
Oh, and here we are. Just the Derek
part
isn't working well today.
Welcome. Welcome.
Hi. Great to be here.
How are you? I know. I got to say, what people don't realize who are tuning in is that it's very, very late or early, depending on which you look at it, for Vinos. So we really appreciate, you staying up late or getting up early, depending on which way you look at it.
What time is it exactly, Vinos?
It's 1:20 a.m. and I have like a Red Bull. And like IntelliJ. I don't think I get to do this a lot, so it's almost like taking me back to my grad school days. So thanks for doing that.
Hey, no worries. So Vinos, for people joining and who may not know who you are, do you want to give us a quick intro?
Yeah, sounds good. Absolutely. Hey, everyone. Great to meet the community here. My name is Vinod Chandar. I serve as the PMC chair for Apache Hudi. So also the original creator of the project back when it was created at Uber. Been with the open source community and also been partnering very closely with AWS for the last 3 years. And most recently, I'm also a new startup founder. We were my day job. I am founder CEO at OneHouse, where we are building a managed data lake service around Apache.
Yeah,
So great to be here.
Cool. Good stuff. And actually, one of the things that we talked about reInvent at the beginning of the show. Okay, you are going to be at reInvent, right? I've actually shared it in the newsletter. We've got you've got a number of meetups, right? So if people want to kind of get to know you, One House, and get to know more about Apache Hudi and the community, then it's in the newsletter, folks. So we'll share that. But you're going to be and we've got it down there on the scroll. So you're going to be there with your community, right?
That's awesome. And I think I heard the earlier remark around hoodies. We'll actually made some hoodies. I'm actually wearing a black hoodie. Like we made like a white white. So if you want a hoodie, swing by the meetup as well.
Hey, good to know that.
All right.
So Vinod, so what are you going to show us? Tell us more about what you're going to show us today.
All right. So actually, this is like a pretty interesting thing I did. I will at least I think so. So I usually do a lot of like slides when we talk about Hudi and kind of take through an intro of the project and sort of like a tour of the project basically. But we also made like a pretty hands-on demo just to showcase how Hudi brings a fundamentally new way of like actually building data pipelines, incremental data pipelines on top of your data lakes. And for this, I've actually turned my IntelliJ into a mini PPT / like, we have like an entire presentation. All done in IntelliJ.
Nice.
So we'll see how
like that.
Shall I put it up?
Yeah.
Let's put it up and let's see it.
We're here.
Yeah. All right.
Mark down for the win. Mark down for the win. So let's start from the beginning. So for those people who aren't even familiar with Apache Hudi, what is the problem, Vinod? How do you typically, if someone's in the elevator and you say I do, they see your Apache hoodie, right? And they say, what's that? How do you answer them?
Yeah, so it's pretty simple actually. So data lakes were, as you know, the files organized on top of cloud storage in S3, right? So what Hudi really did was it brought transactions, updates, deletes, and change capture, things that you would find in databases on top of to the data lakes, so that now you can actually take a Hudi table. A Hudi table is a collection of data, metadata, a file layout sitting on top of your S3 bucket. But now you can do transactionally update records as of a point in time, be able to query a snapshot of the table, and then also be able to consume change records. So these like pretty simple primitives, as we'll see, unlock very fundamental changes in terms of how we process data, starting from ingestion to actually transforming the data to also has like implications on data freshness and efficiency and whatnot. We'll talk about all that as we go.
Okay, awesome, good stuff.
Nice.
All right.
Let's get into it.
All right. So actually, let's ground this on real world example, right? This is kind of the how we ended up creating the project in the first place. So I talked about a file based data lake, right? So this is what we had. This is like circa 2015 inside Uber. I joined Uber as a third engineer on the data team, and then as you know, like Uber's like growing really really fast at the time. So really, it's an actual very real-time business because if it rains, it's going to change the pricing and things do move very in real time. And we had a ton of data, right? So we had our file-based data lake where we were actually doing what everybody did, which is there's a Strips database, we do CDC, we get the change logs, but how do you apply that? We don't know how to apply them. So we will actually bulk ingest them every 8 hours. It's like a 120 terabyte table, right? And the actual change was just like less than 500 GB. Then again, you would build more downstream tables out of them, and there's no intelligence whatsoever. Batch processing, the way it works is you run a job, you give it like a number of partitions or a full table to actually run on, and then it just it's stateless. It just keeps recomputing that result over and over again. So what would happen is sometimes, let's say, even if let's say the upstream database has problems or the data isn't even coming through, these ETLs would run. They're not recomputing anything new even, right? But they would run. So there wasn't any intelligence in the system. So we actually moved, applied Hudi, these primitives, updates and change capture to actually sort of build what we call the transactional data lake, where we could take these change logs, apply them to a table on top of the lake, and the table had transactional guarantees. It had databasey features like indexing and whatnot to be able to observe within the 10 minutes. It's still not real time as in within seconds, right? But this is near real time, good enough for almost 99% of analytics, kind of downstream processing, if you will. And then you change these change events, incrementally process them, and then end to end we can actually build derived data sets within an hour. That was fantastic for us. And and just
can I ask a question there quickly? So
sure.
So you got at the top, you moved from the story from your right hand side where you had to do literally everything to then changing effectively to this format where you were able to just do the deltas, right? So you had lots of advantages, like you reduced amount of actually data that you need to process. You had these different capabilities, like sort of ACID transactions you could do. But one thing that in my head I'm trying to get my head around, okay, is that what actually is it? So with a database, I know it's a database file, right, somewhere, okay. But with a data lake, are we talking about like a CSV files? Are we talking about text files? Are we talking about, so how is that data? Are you running some sort of kind of crawler or something to actually generate the raw data into something else? How does that piece work?
Yeah, that's a great question and a good segue to the next slide,
okay,
which
cool.
is the files here that we're talking about are Parquet files. Apache Parquet is a good columnar file format. So even on the previous slide, right, when we say file-based data lake, these are Parquet files. Okay. The problem with Parquet is fine, but the main issue here was, let's say you have updates, then only a part of the table gets updates, right? Let's say your table has 10,000 Parquet files, but the updates are only touching let's say 1,000, right? Yeah. So Hudi lets you only rewrite 1/10 of your table and not all of the table, right? So that is the intelligence Hudi builds. So that is sort of the simplest version of a table type that we have in Hudi, which is called copy and write. So all we do is, okay, if there's a write, even if there's single record that changes in a Parquet file, we have an indexing mechanism to quickly figure out which Parquet files got affected by this write, okay. And then we version them, right? That's as simple as that. And
so can I ask a question then? So when you say write, okay, copy on write, what's doing the writing?
Yeah, so the writing could be a Spark job. It could be a Flink job. And some more common things that
right. So those jobs, they implement the Hudi libraries, and that's what allows it to do the write. Okay, is that how it works?
Yes. Okay. So if you are on the AWS ecosystem, you would use something like Glue or EMR to actually write a job that would take data from somewhere else and issue updates against your Hudi table that sits on top of it.
Okay, awesome, excellent, brilliant, thank you.
All right, cool. And just to complete the picture here, right? So think of this as now a database, right? So what does the database do? It organizes files in some sort of way, so where it's optimized for either reads or writes, right? It balances the cost between reads and writes by sort of how efficiently it's organizing things, how it takes some updates. So we also have another table type where we call merge and read. The big difference between copy and write and merge and read is that, so in copy and write, even if, let's say, remember I told you that even if a single record in a Parquet file got changed, the entire Parquet file is rewritten. Yeah. It's very simple, right? But we absorb all of the cost on the write. So the query speed remains unchanged. It's almost native Parquet table that you're querying for copy and write. But merge and read, what it does is it queues up these deltas in some log files that we have. We have our own log file format within Hudi. And then it essentially, for when you want to query, it can merge a Parquet and change logs and give you the latest snapshot of the table, right? And then a background process, just like with any other log structured database that you will find out there, a compaction process would run and actually merge these change logs and produce new Parquet files, and life
Right.
goes on.
So that compaction process, okay, does that run as a glue job or a Spark job, or is it run as like a server process? Do you have like a server daemon running somewhere?
No, so this is like a totally, so far at least, like it's been like a very it's a serverless or a headless kind of architecture where exactly like you can schedule a Spark or a Flink job in EMR or Glue or Spark or something, and then that's what it is. So every component here is horizontally scalable, and this was the actual real. So going back, right? I think the biggest contribution Hudi made, I would say, is this architecture, because everybody else at that point were building a very serverful architecture. If you wanted like a more database semantics, you need to go to a serverful architecture, right? So this actually balanced a really good trade-off between not having like serverful components, which will actually affect scalability for like these levels of volumes, right? And still let you do transactionality and more advanced capabilities like updates, deletes. So that was the cool,
okay. So if I understand you right, Vinoth, okay. So what I heard, and maybe I got this wrong, is that you can do this a number of ways. You can go down the server road, okay, to do this, or you can just basically just use the file. So effectively, what we're talking about is we're actually just doing this stuff on files, right?
Yeah.
And effectively, and then having libraries that allow you to write, read, and understand how to do the files, and then you leave up to the system on how it scales, right? So is that right? Is that right understanding? So basically, you can. Okay, cool.
Correct. So Hudi, you can think of Hudi as like a database library that you embed within Spark, if that makes sense.
Yeah.
Like,
that makes a lot of sense. Yeah. Okay.
So, Vinith, I'm fascinated by merge on read because I haven't seen that before. How do you detect and resolve conflicts on merge, which is the complexities usually you'll find on a merge?
Right. So we actually have a core abstraction around like users can author how they want to merge different files, and we even have support for late arriving data, merging based on event time, and all of those different concepts. We do have like core abstraction that can support custom merges. And if you're familiar with CRDTs, like CRDT style, like collision resolution and all of those things are supported.
Yep. Nice.
Cool.
All right. Cool. So then quickly touching upon queries. So then with this kind of like, file organization, we also support sort of like, 3 logical ways of actually querying the table. So one is what we call a snapshot query. It merges the changes. It provides you a consistent snapshot as of a point in time on the table. This is like your, normal database query, if you will. You say select star from table, right? And the second one is what we call it's something that I think has like, I would say, the consistency of the data that's returned here. It also depends on how we are running compaction, but it has very practical use cases in real world. What it really does is, even on an MOR table, it only queries the Parquet files. And often where we use this is, let's say you have like a GDPR kind of use case. So your same table, you have like, your regular ingestion, the normal data coming in. And then you also have like a, bunch of like backfills or historical data being deleted in much older days or older, partitions of the folders of the table, if you will. Then actually what this lets you do is, Hudi also gives you lots of flexibility on what parts of the table do you want to compact. So you can leave the most recent data fully compacted, and then you can query that through read optimized query. You'll actually get the latest state, while you can batch up. Most companies have like a 24-hour window or something before which they want to enforce the GDPR or these kinds of deletion SLAs, right? So you can actually let the cost of the deletes be amortized over a few hours and then compact them at a later date. So that's why we have the read optimized query. And also like large machine learning jobs, maybe you don't care about the data freshness as much. You just want to do more pure columnar performance. So it exists for those kind of scenarios. the incremental query is straightforward. It's your database CDC query, of course. So you can go ask a Hudi table, give me changes that happened on this table from this point forward. So it'll give you everything that has been, inserted or updated from that point.
Nice.
But I have a question from the chat. I'm not sure if you can answer it because I'm not familiar of what Databricks Delta Lake or Apache Iceberg, what the functionality is, but you might know what Hudi provides that they don't.
So I think I would say Hudi's. Okay, there's actually a pretty detailed blog on OneHouse, and I even have this down the slide where you can actually a bit link for. But very high level, if you have to answer that, so Hudi is like a lot more suited for like mutable workloads, like because we have like an indexing subsystem. Hudi, like something like MOR, merge and read. It's these are things that have been supported in Hudi for 2 years, right? So you won't like MOR indexing, lot better concurrency control, and as I get into maybe like the actual components of the project, Hudi is actually a pretty big platform. So we have like, for example, a bunch of like ingest tools, catalog sync mechanisms. There's like actually a lot more functionality and platformized capabilities in Hudi. A lot more support for authoring incremental pipelines and update heavy workloads than what you would see, I think, because the projects has always had from the start that goal towards making incremental processing kind of like possible. That's the I eventually built this project. It's actually a good segue into actually touring sort of how the project's laid out, right? So we depend on object storage and open file formats. And on top of that, what the first layer, what we have is the layer that provides all of this transactional database capability. So you'll find components. So the like a table format is like one part of it. Essentially, we have a metadata table, which can also store schema, wide file listings, serve statistics and evolution and these things. But then we have like a full comprehensive set of what we call table services. If you're familiar with databases, think of them as database daemons, right? Every database in the world has some like daemons who's doing some, management of the data tables underneath, right? So we have like daemons that can do like cleaning, compaction, clustering of the data, z-ordering, and all these kinds of storage layout optimizations, indexing subsystem, which can actually, just like Postgres, you can create an index, be rebuilding it in the background while writes are happening. So these kinds are like concurrency control mechanisms and services that can like actually tightly integrated with one another. So Hudi has a bunch of these services as well. And we have, I think, like 6-7 types of indexes. As you know, there's no one size fits all there. There are different workloads people run into. People have like random updates. People have, like more like specific write patterns to it. So yeah, we support a bunch of index types for you to optimize your sort of like update or write performance over that. So these are, and then on top, we sort of like support snapshot queries, time travel queries, incremental queries, as I covered. And we also do key enforcement, and we integrated this point with pretty much all the major lake and like even warehouse query engines. And if we actually find that a lot of people for these common use cases just use our platform services. A lot of the users are not actually even aware of the lower level technical details. So that I think has been the great thing to see in the project, and it's actually been a very community driven effort to get to this point.
So I've first seen the layers of Hudi, because like lots of people, I thought of the table. But I was seeing the layers. I was like, wow, this is very impressive indeed.
Yeah. So the transaction database layer. Okay. So going back to my question earlier on. So these aren't running as a server. These are running as executables that you run as you want. okay, when you want. Is that right?
Correct.
Or okay.
Correct. And so here is where I think going back, right? We actually have a runtime of sorts where after every write, this is like let's say you write a Hoodie Spark job, you pull in the you write a Spark job, pull in the Hoodie library, and then you issue a write, right? By default, Hoodie can run some of these services inline, for example, for you.
Okay. Right.
So that's another key difference. It's not us. We built it as a, again, like going back to I had a lot of inspiration from like embedded databases like Berkeley DB, RocksDB, these kind of systems. I used to work with them a lot deeply while I was at like LinkedIn building a key value store, right? So that's the kind of model that we try to do. You issue a write, and after the write is done, it the Hoodie can kick off the cleaning for you. Cleaning is something that keeps the number of file versions in check so that your storage costs are bounded, right? And then it can actually evaluate, oh, I wrote new data to the table now, should I compact something? It can run a check, you can run a strategy, it can figure it out, it can schedule a compaction for you, right?
So it's opinionated.
It's opinionated. You can so more than opinionated, I would say it's feature rich. It automates a lot of this TDM around table management for you out of the box, right? And then you can configure it just like how you would go to one of these embedded database, let's say RocksDB, and you would say, I want level compaction, or I want like this style of compaction. You can say that, and it'll actually do that for you as a part of the write. That is the key.
Okay, cool.
All right. So
awesome.
All right. So I'll maybe like so this is the Bitly link I was trying to show you. You can just do like Bitly Hoodie feature comparison to read the blog.
I put the feature comparison in the chat. So if anybody wants to have a look at it, it's all there.
Got it. And then I'll do like a quick like touch upon like here I want to like say save some time for the demo itself. I think it's a pretty interesting one, I think. So yeah, within AWS, right? This is been the timeline of the project. I think we created it at 2016, open source 2017, and then for I think the last 3 years we've been pretty like we're working pretty closely with the AWS teams and being like more deeply integrated within the AWS ecosystem. So today, what you'll find is this is typically how kind of what we've seen people usually use something like EMR, use like Flink or Spark with Hoodie to do some real-time, near real-time ingest. Then people also use Glue, and then do like a more like a serverless sort of like way of writing Hoodie. And you can then query this through Athena, Redshift as well through Spectrum. And then you can write a whole bunch of batch jobs on it if you want the good old like batch jobs. You can still write them.
So in the diagram you got there, the Hoodie piece there specifically being the libraries to read and do all the querying, right, of the Hoodie files in the S3 storage.
Got it. So to your question, right? The questions around like servers, for example, the servers are all provided by EMR or Redshift or systems. The Hoodie is a library that embeds across all of them and just concurrency control and kind of transactional, and it knows how to safely operate on that one shared table that is sitting in S3, now being written from EMR, read from EMR, read from Athena, read from Redshift, right? Nice. And this gives you like great optionality because now you have like 3 engines sitting on top of the same table, right?
Yeah, totally. And I guess also it means that it's very portable, right, as well because of that.
Yes, exactly. So if you macro thing is like if you look at the overall open source community, even outside of open source, like we work with all the open source engines, like the just the open source projects level as well. So with a layer like this, you have like pretty much unbounded kind of, you can choose whether you want to use the open source project or buy, there's usually a company behind the project. You can either buy a query engine from them or you buy from a cloud provider like AWS, right? So this opens up all those possibilities for you without migrating data, which is I don't think anybody enjoys doing any of that.
Yeah.
All right, cool. So with all this said, right, I actually wanted to take like a very concrete use case. How much time do we have? Just for me to.
We've got
15
10
minutes.
Yeah.
Oh,
Okay.
sorry, 10 minutes.
I
We
need
gotta
5
close
minutes.
out.
I need 5 minutes at the end. So yeah, 10 minutes. We've
All
got
right,
10
all
minutes.
right. I'll go fast. So let's take this like like a use case, like just in time for Thanksgiving and also like Black Friday and everything. So shopping cart example. Let's say there's an online retailer who wants to just email everybody. Like people are adding things to their carts, right? Removing them, and then you just want to build something where periodically, like every few hours or every many times a day, you want to essentially email people who abandon their shopping carts, meaning like you added stuff there, but you didn't check it out, right? You want to say, hey, you have items in your cart, right? Very simple use case like that. And then for this example, you have a user profiles, which is like it's a bunch of it looks something like this in the real world, but for if like it essentially contains a user ID and an email. Think of it as like a user table, right? And then as people click through the online store, you emit events to Kafka, and again there'll be like bunch of things. That's how a real event would look like. But the things to focus on are there is like an action type. Maybe they added to the cart, removed to the cart, purchase something, right? And then whether the state of the cart, whether it's empty or not, and then when this happened and when we last saw the user, right? So if you think about this, if all you wanted to compute was, hey, like who has unpurchased items in their cart, here's how you would do it in old batch way, right? You would take these user like event tables, you probably partition them based on day or something, because these events are voluminous, and every X hours you would run a job which will scan last like some partitions here, join it with the profiles to get the email. So you have like all the events, user ID, and an email. Now you'll take an existing target table and you'll merge and rewrite the whole thing, because I mean there is no other intelligence, right? So this is like inefficient. There's too much data being read, written, data freshness, and then there will be late arriving data, right? The batch ecosystem, all of this doesn't completely ignores the fact that late arriving data, stream processing, streaming events are like a thing, right? So it cannot handle any of that. So this is how we would do this with Hudi. We basically do incrementally fetch new events. So we don't go scan the entire table, or even even today's partition, we don't scan it fully, right? We have intelligence to figure out, like efficiently fetch only the new data, new events that have happened since a point in time. This goes back to our incremental query. Then we do the join. That's a simple like stream table join. And then we update directly the target table instead of rewriting the whole thing. So this thing is like efficient.
So what's a question for you, Vinod? So sorry. What's doing the incremental fetch in the new way of doing it?
Yeah, so I'll show you down the line.
Okay, cool.
All right.
Let's get ahead.
Yeah. So essentially, it moves data freshness to kind of like almost near real time, right? Now you can do a lot of these intraday sort of like things. We could do fraud checks very quickly. It opens up a lot of possibilities for you, all of us that are on your lake. And it can correctly deal with late data, as you see. So with Phi, I'll actually try to just walk over the thing than actually running it. So here is the setup, and I actually pushed it out as a public repo. I'll share that with everybody as well. So all you need for this demo is like Kafka Spark installed, and then like spin up a Spark shell. So Spark and Kafka pretty much, and we package some test data here. So essentially, the first step is all we are doing is just like getting some CSV loaded and making this user table. That's all, right? And then if and this is just like we make mark some data for the user events. So we are pumping these events into Kafka. That's it. So So Hoodie has this remember I was talking about platform services and all of that. Hoodie has like this tool called the Hoodie Delta Streamer, the Hoodie Streamer, if you will. And here is what this one command can actually just you can just ingest from Kafka. Like it'll just run continuously running Spark job, and it'll I was trying to see if I can show you some runs from this. It essentially will keep just running and then sleep if it doesn't have any work. And then Spark dynamic allocation means it'll shrink the resources down. When it has work, it'll shrink, it'll expand again and do it. So quite literally, this one command can create a well-managed Hoodie table out of Kafka. So what we managed to do here is we now managed to ingest the user events table, right? And while this is running on, and you can now query this table, do some I'm just showing you that you can write some snapshot queries. Not very important or not very interesting. Maybe this is the most interesting thing. This directly answers the question that you were asking, right? So here is how you fetch data. So you say you want to fetch user events from commit time 0, right? Which is like time 0. So that is your your initial first round of compute. You don't have the target table even, right? And then so this will fetch for reader for kind of viewers who are not familiar with Spark data frames and stuff. This will essentially fetch all new data that has happened in the user events table, which is essentially our first batch of data that we played into Kafka. It'll read this out into this kind of essentially like a data structure, essentially, right? That the Spark data structure called a data frame. Then if you look at what we do here, we just do like a join. We are doing the second step of we just joining our user events against the profiles on the user ID, and now this is where now we are doing the update, and I'll explain this a little bit more. So Hoodie supports keys. So you can this target table, which is user card status, essentially it's keyed by user. So what we are tracking here is for every user, what is the last seen time, what is the card status, and as you can imagine, right, this is a simpler like override use case, but the events can be out of order, right? You could have maybe there's a Kafka broker change, or there's something else, something happened, right? Maybe you viewed it on a mobile phone and you went through like an elevator. Anything can happen, right? And then you can get out of order events. So here is what all that has. So what we do is you configure something called a pre-combined field, where you say, hey, if I get 2 records for the same user ID, which one should I pick? So this Derek, this goes back to like your question on how we do the conflict resolution, the ordering, right? So this is very reminiscent of streaming systems. This is how like Flink or Spark or Kafka streams or all these streaming systems resolve for consistency. So yeah, we just do the update here, and then essentially you pump some more data, let's say the second batch of data, and then you repeat the same thing. Essentially, you fetch the new data. This time you provide this is like a checkpoint. Basically, you say, okay, my target table is up to date till the first commit. So you pass in the first commit time and say, okay, now give me everything from the first commit. So then, yeah, it's exactly the same thing that you saw there. And this is basically now turned what was like essentially like a batch thing into something very incremental that you can now control, right? All this and a good tip here is, if you want checkpoint management, for example, like again speaking to the platform pieces in Hoodie, like the streamer tool that I showed you can actually read Hoodie tables as well. So you can read Hoodie, do transforms, and actually write Hoodie tables and do all the checkpoint management for you. I just use this here to just illustrate how it works in the flesh, right?
Where do
And-
people typically run that streaming tool from, Vinoth? Do you see patterns of where people do it? Is it from an execute environment, or is it from like a Spark job, right, or or environment, or EMR? Where do people typically do those?
Yeah, any Spark or Flink environment. So Hoodie writing today is from Spark and Flink, and reading there's like half a dozen or more queries engines that you can read and transform Hoodie tables from. And we're a fast growing community, and
that's awesome. We love that.
Come join our Slack, and I know we are almost like I'm encroaching 1 minute into your time.
No, don't worry. Don't worry. It's good.
It is so you can find us, and there's a lot more. Come join the community. That's my last.
So we are wrapping up now. We are wrapping up. Derek, I think we got the final transition.
We just if all the links for today's show is on a GitHub repo if you want to get them and you've missed them now. Let me get back on. I've heard the bell. That's
you heard the bell. Transition.
You might have to do it again.
So Vinoth, I forgot to ask you. We have the Tech Pineapple on Pizza Challenge board. Right, so this is where we find out really what we really need to know, what the community is really asking. Okay, is do you, when you buy pizza, and do you like pineapple on your pizza, or are you disgusted and walk out the door? We need to know. The community needs to know which side of the fence are you sitting on?
Extra pineapple, not even
extra
pineapples.
Oh yes. See, this is it. You are
right at the edge.
You are joining a select crew. You are selecting a correct crew, and we love you for that. So thank you, Vinoth, for going through and walking through that. I certainly am much clearer now about what Apache Hoodie is.
Yep.
For people who are joining either now or who are watching the recording afterwards, we're sharing the links of the demo and the code that Vinoth showed. Try it out, run it. And get in contact. Tell us what you think about Apache Hoodie. We've got the next show. So as we wrap up, next show is going to be on the 16th of December.
4 weeks, Rick.
It's in 4 weeks' time. We've got AWS community builder Ran Eisenberg, who's going to be talking through some of his open source projects. We will be at Derek and myself will be at reInvent. In fact, Vinoth, you're going to be at reInvent as well, aren't you? So so we're all going to be at reInvent in 2 weeks' time.
I'm going to be the most jet lagged.
Well, that's true. You will, and I probably will be a little bit, but not as much as you. So help Derek. If you see Derek, give him coffee. Buy him Red Bull.
Yes, lots of it. I want what Vinoth's having. I just posted a link in the chat that Vinoth just shared of the demo. Oh, somebody's already done it. You're already there. Sorry.
Yes. It's all right.
It's organized.
So come find us. Like I said, I will have some of those coins. Go check out the Apache Hoodie community meetup. It's going to be awesome. I'm going to try and because I think there's about 4 or 5 sessions you're doing it, aren't there, Vinoth? I'm sharing it in my newsletter. So if you want more details of the meetup, then they'll watch out for the newsletter, which is published on Monday. If you want access to the newsletter before anyone else, then this is the link to get it. So you can get a newsletter using that QR code. It's a very short survey, 5 questions is all I ask. But with that, I just want to say thank you again, Vinoth, for sharing your page and your enthusiasm for your Apache Hoodie project. Looks awesome. Are there any final words of wisdom you want to depart for the community that are watching?
No, not wisdom, but I'm really looking forward to meeting more people in reInvent. A lot of this happened through the pandemic, and I don't think I've had a chance to meet even a lot of people that I worked through it. So I'm really looking forward to meeting people in the real world.
Awesome.
I think if anybody sees the show, Vinoth, they're going to want all their demos and all their presentations to be done via IntelliJ. That's the first for me.
A world first. Okay, with that, we're at time. Thank you again, everyone, for watching. See you again in 4 weeks' time if not
Yep.
before at reInvent. So
At reInvent.
see you
All right.
later, everyone.
Be safe.
All right.
Bye.
Have a safe
Bye.
flight. Bye.
Bye.